So welcome to a new tutorial. Today we're going to start with data types in Python. I'm going to go over the data types that Python supports and help you understand those, and we'll work our way up from there on. So a bit of a refresher first. What are data types? Data types, put simply, are the way you classify or categorize items. In other words, they represent a kind of value which determines if you can perform a certain kind of operation on that data. So let's say we have a number, right? Imagine that a number is a data type. So how are you categorizing such entities? You are categorizing them as numbers. And what kind of operations can you perform? Addition, subtraction, multiplication, division, and all such operations. So a number seems to fit both the categories that we define for data types. Hence, the term data types. Now, Python, or more specifically Python 3, supports various kind of data types. The various data types are listed in the python.org documentation, which you can definitely go ahead and look at. But we will start with the simplest ones first. The first category of data types are numeric types, and there are three subtypes under these: int, float, and complex. Now, if you remember a bit of math from your school days, you would remember that integers are positive or negative whole numbers, and they don't have a fractional part. So on this interpreter on the right side, 1 is an integer, 0 is an integer, 1 4 1 4 4 4 1 4 1 4 4 4. I lost count of the 4s there. This is also an integer. Okay, moving on, there is another kind of subcategory called floats. Floats are actually real numbers which have a fractional part and an integer part, and both of them, when clubbed together, are termed as floating point numbers. So something like 1.23, 3.5, 3.14, if you remember, is the value of pi, are all real numbers, or in Python terminology we call them floating point numbers. Now there is a third category of numbers called complex numbers. This is a bit of a higher mathematical concept. Complex numbers have a real part and an imaginary part, and you can perform certain operations on them like addition, subtraction, even multiplication and division, but certain other operations are not possible for complex types. In Python 3, there is inbuilt support or native support to represent complex numbers, and for that you use the keyword complex. So as you can see that it says complex of 2 is represented as 2 plus 0j, which essentially means that 2 is the real part and 0 is the imaginary part. Similarly, okay, so that was a refresher on the data types that Python 3 supports, the numeric data types. A bit of a digression. There is a handy little helper function called type in Python that will help you determine the type of the data or the data type that you're working on. So if you go to the documentation of the type function, you can see that it expects an argument, object, or name. And it will give you back the type of object that it supports. So for example, if we were to pass in type of 2, we expect to get back an int. If we were to pass in type of complex 2, we would get a type of class complex. If we were to, let's say, pass in type of 3.14, we get a class of float. Super. So those were the numeric types that Python supports. As you can easily imagine, simple operations should be supported on these types. So if I were to do 1 plus 2, I should be able to get a 3. If I were to do 2 minus 1, I would get a 1. I can also do operations across data types. So if I were to do 1 plus 2.3, I expect to get 3.3 back. Now, That might seem intuitive to you, but how the Python interpreter works in this case is it sees, oh, okay, I got an integer and I got a real number. So real numbers have higher precision than integers. So what it does is it goes ahead and upcasts the integer such that its type matches the type with the higher precision. So in this case, 1 actually becomes 1.0 and 2.3 remains as is. Then you get back a 3.3. Cool. You can expect the same operation to happen with a complex number. In this case, I should get a 3 plus 0j, which is exactly what I get back. Cool. Moving on. Now, along with these numeric types, there is another kind of data type called the Boolean. Now, Booleans are like switches. They represent two states, true or false, on or off, however you might want to call it. In Python, you represent trues as a value like this and false as a value like this. Pay careful attention to the first capital letter for both words. Now, in some other languages, for example Java, trues and falses are represented as all lowercase letters, but it is not exactly that case in Python. Cool. Now, those are not the only ways that you can represent true or false values. A value of 1 is a true value, and a value of 0 is a false value. An empty string is a false value, for example. We will get to strings later, but for the sake of simplicity, imagine something that makes sense, or something that is truthy will always evaluate to true, and something that is falsy will evaluate to false. So an empty string or a null string signifies that there is actually nothing there. So that would be a false value, whereas a non-empty string or a non-empty data type would represent something being present and would evaluate to true. Cool. Those were Booleans. Now, moving on to the meat and potatoes of data types supported by Python, we come to the third type of data called the sequence types. Now, as you might understand, as the name suggests, sequence types kind of encapsulate sequences of data. They could be strings. For example, Python is a sequence type, and it's a sequence of characters, ASCII characters to be specific. What is the type? I expect the type to be a string. Now, Python supports two other kind of sequence types called lists and tuples. You can quickly go ahead and check the types here. The type is a type. That is interesting, right? So when you see the type as a type, it is actually referring to a sequence type. I expect the same output for a tuple, and voila, that is what I get. Now, in Python, you represent lists in this particular fashion. Lists are storage containers of heterogeneous kind of data. So what I mean to say is that in a list, you could store numbers, you could store strings, you could store characters, or you could store a mix of any kind of data type. So there could be numbers as well as strings, or numbers as well as characters in your list. That is your list. There is another kind of data type called a tuple, which is defined so. Now you might be wondering that the two data types actually look quite similar. In fact, they do look similar, but they are not quite the same. Let me show you why and what I mean by a small example. Let's try adding some, let's try changing the value in either of these sequence types. Let's say we take the second element, assuming 0 indexing. The 0th first and the second element would be 3 in both cases. Let's try to change the value for the list. Let's try to change it to 4. Cool, we were able to do that, right? And we changed the 0th element and it changed to 4. So what do you see? It's mutable, right? We were able to change the value in the list. Now let's try the same thing with the tuple. So boring. Probably we should be able to do the same thing, right? Bam! Turns out that is not possible. So that is the biggest point of difference between lists and tuples, right? Lists are mutable data types and tuples are immutable, which means the moment you assign a particular tuple a value, you really cannot change it unless you go ahead and explicitly destroy the reference to that particular object. We will talk about references later, but think of it this way. You can change values in the list, but you cannot change values of the tuple. Otherwise, they're pretty much the same. Oh, cool. Those were sequence types. Okay. I hope by now you have a fair bit of idea in the way we are progressing, right? Feel free to add comments and let me know what you think. Moving on, the next kind of data or data type are dictionary types. And as the name suggests, dictionaries are like unordered collection of data in a key and a value format. So something like this would be a key of a1 referencing a value of 2 and a key of 3 referencing a value of 4. If I were to go ahead and look for the type, I should get a dictionary, which is exactly what I get. Now, the advantage of dictionary types, and mind you, they are enclosed within curly braces. That is actually important. There are other ways to initialize dictionaries. We will get to that later. What is the advantage of dictionaries? Anyone? Yep, that is correct. Dictionaries let you do O1 lookup of data. What do I mean by that? So imagine you were to go ahead and have a collection of addresses and people referenced by those addresses in your address book. If you were to represent that as a list, and I were to ask you, hey, go ahead and give me the address of Mike, you would have to parse the whole list or the sequence, and when you would find a match, you would be giving that back to me, right? So in essence, you would have to go over all the records in the worst case. However, if you were to do it with a dictionary, you would use the person's name as the key and their address as the value. And if I were to ask you for the address of a particular person, you would do a simple key lookup, right? And bam, you would get the address back. So this is where dictionaries really shine, and this is what the use case of dictionaries is. To have an unordered collection of data and to be able to look up the values by keys. Cool. So what I mean by that is, if I were to find out the value referenced by 1, I would be doing an A1 and I would be getting a value of 2 back. If I were to do an A3, I would be getting a value of 4 back. Now what if we do, or what if we try to look up a key that does not exist, right? Let's try A0. Oh, okay, which it fails. The error is pretty straightforward. It says a key error of 0, which means, hey, the key does not exist. Why did you try go and look up that? Now, there is another way to reference values within dictionaries, and that is by using an inbuilt method on dictionaries called the get method. What the get method does is it provides a safe wrapper around this key lookup, and essentially if the key does not exist, it's not going to fail, it's not going to throw a key error, but it's going to return you a value of none. It signifies nothing was present there. So if you were to go ahead and do an a.get0, it didn't fail, right? But what value did we get back? Let's try to see what the value is, right? So the value is none. There's no value there. Can we assert the value? Yeah, that is correct. So the value was none, signifying that there was nothing. The key was not present. Cool. And those are dictionaries, right? So that was all about data types that Python supports. In the next lecture, we will be talking about functions and how to write them in Python, and we'll try to do some cool things with them. Until then, keep watching, and if you like this video, go ahead and hit the subscribe button and show me some love. Thank you so much. Until next time, see you. Bye bye.